Alright, let's move into problem number 23 now. So this problem defines something called abundant numbers and something called perfect numbers. For example, 28 is called perfect number because all of its divisors 1, 2, 4, 7 and 14, if we sum them up, that becomes 28. That's why it's a perfect number. But there are other numbers where if you just take all the divisors and sum them up, it can be either less than or more than, greater than numbers. So when that sum of the number of divisors are more than the original number, those numbers are called the abundant number. Now 12 is the smallest abundant number. Now if you add 12 plus 12, that becomes 24. So 24 is the smallest number where you can represent this number as a sum of two abundant number, because here two numbers are same, 12 plus 12. And it also says that it can be proved that 28,123, any numbers more than 28,123 can be represented as a sum of two abundant number. Therefore, we'll have to find out all numbers that cannot be represented as sum of two abundant numbers, and we'll have to find the sum of all such numbers. That's what the question is asking. That means our search will end at 28,123. We'll have to find out any number less than that. If that number cannot be represented as two abundant number, then we take this number, otherwise we reject it. That's going to be our problem. Now let's jump into our coding. So here basically we have multifold problems here. First we'll have to figure out how to calculate all the number of divisors. Okay, for every numbers. Then we'll sum them up, and then actually we'll try to find out what numbers can be represented as sum of the two abundant numbers. Then if we reverse it, that means those numbers which cannot be represented as sum of these numbers, and that's what the question is asking. So before we move on, okay, let's first think about it, how we can calculate the number of divisors for all numbers. Okay, now we can do it very simple way, but the problem is we'll do too much of calculation. Instead of that, we'll try to figure out some interesting property. I'll take that with an example. Let's say we want to create a number of divisor of 24. So we know 24s can be written as like this: 4 multiplied by 6. Now if we take all the divisors of 4, it becomes 1, 2 and 4, including that number. Okay, and if we really try to find out all the divisors of 6, it becomes 1, 2, 3 and 6. Okay. Now if you just multiply 1 by all this number, then 2 by all this number, 4 by all these numbers, what do we get? Let's try to find out. We get 1, then 2, we get 3, 6, then we get 2, 4, 12, not 12, 2, 4, 6, then we get 12. Then if we start multiplying by 4, we get 4, then 4 into 2, 8, then 12, and then 24. Now you see there are some numbers are duplicated. Okay, if we just remove all the duplicates, what we get? Quickly what we can do is we can take this as a list. If we remove all these duplicates, okay, so these are our list. We just do set of the list. So these are our distinct numbers: 1, 2, 3, 4, 6, 8, 12 and 24. Interestingly, if you try to find out the divisors of 24, that's exactly what we'll get. So that means in order to find the divisors of 24, if we take any of these multipliers like 4 and 6, and if we find out the number of divisors of those individual numbers, then we can calculate for the main numbers. We don't have to do the whole calculation for the main numbers. As long as we know the number of divisors of the lower number, that should be enough. So as a first step, what we'll do is we'll just create a list multiplication function, just like that. Div, because this is a list. Okay, I said this is a list and that's another list, and if we can multiply this to a list and return the distinct number of it, then we get the divisor of it. That's why I'll just get a list multiply function. Okay, so list 1, list 2. Here what I'll do, I'll just create a list variable like that. Then for number 1 in list 1, we have number list. Okay, for number 2 in list 2. Then what we'll do is we'll just append list dot append this number 1 multiplied by number 2. Okay, and then what we'll do is we'll just return list. We'll just return basically the set. Let's create the set of list and then convert it back into list, because we just interested for list. So that will remove all the duplicates and give us the distinct things. So for example, if we just want to test it, list multiply, in our example, if we just pass this to list, let's say list 1, and I'm going to copy this one too. You see we got 1 3 4, and these are exactly all the divisors of 12 or 24. Okay, now let's try to find out let's try to create a function which will calculate the divisors. So what we'll do is we'll just create another function just like that. We'll say def get all div, then we'll just take the number. Then what we'll do is, let's say divs is our variable where we'll create all the divs. Now we are just trying to find our one divisor. I'll say div in range 2 to number divided by 2 plus 1. We don't have to go until the whole number, because minimum we have already taken care of 1. So minimum next divisor has to be 2. That means we don't have to go more than half of this number. That's how we have done this. Now what we are doing is, if num modular division by div equal to 0, that means the div is a divisor. Now what we'll do, we'll just divs.append div, and we want to return. Okay, now because we found one div, what we can do, we can split this number as two parts. One is one part where we have already accumulated number of divs. Another one is if we just divide number by div, then we get another number. And if we just recursively calculate the number of divisors of that number, then use list multiplier, then we get our number. Okay, so basically we'll just do it like this: list multiply, the function which we have created. List multiply, here we pass divs, then we call get all, let's keep it get all divs, and again I'll just get all divs, which is plural. So then what we'll do is we'll just create num divided by div. So we get two parts. The first part division we already calculated, or we are accumulating it. Second part is when we are dividing it, then we'll recursively calculate it and do the multiplication of these two numbers. That should give us our intended number. Now here we also have to add divs.append. At the end of it, we know the original number also has to be appended. Okay, we want to keep the original number as well, and then finally we'll have to return divs. Okay, so let's just quickly test it. Get all divs. Here what we'll do, we'll just pass 24, let's say. Okay, you see we're getting it. Now let's say 56. Yeah, we're getting it. And yeah, so one thing we have noticed that these are not sorted, so we'll just sort it at the end, but we are getting all the numbers. Okay, next what I also want to do is, basically let's create a dictionary. Okay, basically we want to calculate all the divisors for 2 to 28,123. We want to create a dictionary of it. So that's why we'll create a dictionary. Type dictionary equal to, let's say, an empty dictionary. And what we want to do, for I in range 2 to 28,123, because that's our search range. Then we create div dictionary of I equal to get all divs I, but we'll just save it as a sorted manner. Okay, because we're not getting in the sorted order. But one more thing before I execute it, let's think about it. Okay, because we are doing it incrementally. Let's say when I'm trying to calculate something around 28,000 or 2,000, okay, some long number, we know that when we divide it, we'll get the number which is less than this number. And because we are already saving it, okay, instead of us trying to figure out from the entire number, we'll first have a look into our dictionary itself. If the number is already available in dictionary, we just return it. Otherwise, we'll do this calculation. So what do we mean by this? Let's try it. We'll just do it like that. Return, if any number is already available, return div dictionary of the number. If it's already found, it will return it, and our job is done. Except if it is not finding it, then we'll have to do this things. Okay, we'll have to do this calculation. So that should improve our performance. Okay, so now let's try to run it. Okay, it just took me about 1 second. Okay, now if you look at that, if you just take any number, let's say 272700. Okay, we have this deep dictionary. So this deep dictionary has got all the divisors of every number. Now I'm also taking the original number. Okay, so you can check with any number. Let's say 33, it should be there. Okay, so we got this dictionary. Next, what we'll do is we'll just try to find out the list of abundant numbers. Okay, because that's what is our interest. So what are the abundant numbers? Let me create another dictionary, another list like this, abundant number. Then how do we calculate abundant numbers? It's very simple. Basically, we'll take all the divisors of these numbers, sum them up, and if their sum is greater than the original number, then that's an abundant number. So let's create another loop for that, for I in range 2 to 28,1, 2, 3. We could actually create this as a variable, but we'll leave it like this. If sum of, now we don't have to calculate, call our functions because we already have a dictionary. So we'll just access it from our dictionary, sum of that dictionary. But remember that this dictionary will also include the original number, which is the last number of these divisions, and we don't want that. So what we'll do is we'll just remove that last number. We'll take all number but the last number, just like that. And if this sum is greater than I, okay, then abundant numbers dot append I. Okay. This is if. Okay, now we got all the abundant numbers here. Okay, these numbers are all abundant numbers. You see, it started with 12 and it's going on. Now as a next step, what we'll do, we'll try to find out the sum of abundant number. Basically, we'll try to create all the numbers that can be created as a sum of two abundant numbers. How we can do that? I think we can create a loop, and we can travel with all the list of abundant number and find out that. Okay, let's create another list like abundant bd sum. I'll just create this as a set because if the numbers are coming repetitively, I don't want to save it. I want to keep only one copy of it. So if I just do for number 1 in abundant numbers, okay, we got these abundant numbers. Then for number 2 in same abundant numbers, and then we'll just sum them. If I will sum them, we'll not keep anything that is greater than our upper limit. So if number 1 plus number 2 is less than that same number, 28,001, 2, 3, then we'll keep it. Then I'll keep abundant sum dot append. Okay, this is set, so it has to be add as number 1 plus number 2. Okay, let's run it. Okay, this one took couple of seconds time for me. Okay, now we got all the numbers, all the abundant sum. Okay, now what we have to do is let's create another list as all numbers. Okay, what is all numbers? All numbers will be list, it will be range, basically all numbers up to this limit 28,001, 2, 3, 28,001, 2, 3. Now if we just make it list, so that's we get all numbers. So we got all numbers, and we got all numbers which can be added, created by sum of two abundant numbers. Okay, so the question is asking what numbers cannot be represented as sum of this. So I think we can do it like this. Okay, if we just sum this number, which is this, and then minus it with the sum of this number, because we want what cannot be written. So if we just minus it, and that should be our answer. Okay, that's one way to do this. Another way to do this, you can do a set minus. So basically what I mean is I can do it like this. I can create this as a set, all numbers. Another set is abundant sum. Okay, and then let's say S2. So our S2 contains list of numbers which cannot be written as sum of two abundant numbers, and you can just sum this as well. Okay, so both approach, you see you got the same number as answer. So let's check if this answer is correct. Okay, and I'm logged out. Yeah, our answer is correct. Thanks for watching. That's it for the current lecture. Coming up next is problem number 24. Thanks again for watching.